Let's work on modeling our electrons, filling our shells, and determining the number of valence electrons that might be available. So our magnesium atom has 12 protons. It has an atomic mass of 24, which means that it also has 12 neutrons. And if our protons and electrons are going to be equal in an uncharged atom, we need to have 12 electrons. I'm not going to draw out all the protons and neutrons. I'm just going to draw a circle as our atomic nucleus, and we're going to say that the protons and neutrons are located there. And we need to fill our 12 electrons into our different electron shells. Now, in our first shell, we are going to be able to put 2 electrons. The first shell only holds 2 electrons because it's relatively close to that nucleus, which means that if you have too much energy in those electrons around that nucleus, it's going to cause it to be unstable. So in our first shell around the nucleus, we can place 2 electrons. In our next shell, we can have 8 electrons. So if we're going to get up to 8 electrons, we're going to put 8 electrons in our electron shell. Now, electrons like to be paired up, and this is going to be important in just a few minutes when we look at our chemical bonds. But if we put our electrons in our shell, I'm going to fill them in sort of one at a time, and I'm going to pair them up as I go. So we've got a total of 10 electrons now, which means we need to add one more shell and have 2 electrons in that shell. And remember, those valence electrons are important. Those valence electrons are the ones that are going to be involved in our chemical bonds. And to form a chemical bond, we're going to share, gain, or lose an electron. Now, when we have unpaired electrons in that valence shell, they are going to want to pair up. And they're going to pair up with electrons from other atoms. And that's how we get our chemical bonds. So our chemical bonds are going to come from electron pairing. Now, that pairing could be shared electrons, could be lost electrons, or it could be gained electrons. So in this particular atom here, we have 2 unpaired valence electrons. That means that magnesium can form 2 bonds because there are 2 unpaired valence electrons. Now, students like to say, well, there's 2 electrons. Why don't they just pair? That has to do with the chemical interactions that happen in the atomic nucleus and some interactions between the electrons that we're not going to get into. Let me show you another example to illustrate what's going to happen when you have more electrons in that outer shell. So let's look at chlorine. Chlorine has 17 protons. It is also going to have 17 neutrons and 17 electrons. We discussed in a previous video that chlorine likes to lose an electron. We're going to ignore that for a minute, and we're just going to look at the neutral chlorine atom. So we've got our atomic nucleus with that 17 protons, 17 neutrons. 2 electrons in that first shell. 8 electrons in the next one. 1, 2, 3, 4, 5, 6, 7, 8. So we have 10 electrons now, which means we have 7 more that we need to put in this chlorine atom. So we are going to fill them unpaired initially. And then once we get to 4, we're going to start pairing them up. So I've got a total of 17 electrons. These electrons are paired this one is unpaired. Now it is the unpaired electron that is going to be our important valence electron, because that valence electron is the one that's going to want to react. I said a minute ago that chlorine likes to gain an electron. So because this electron is unpaired, it's actually going to pull in an electron from another atom and fill that empty space. So now that electron is going to be paired with an electron from another atom. And we'll talk about what is actually happening there in just a little bit. But for now, just keep in mind that those valence electrons, those unpaired valence electrons, are going to be the ones that allow an atom to form a bond. So if we have one paired valence electron, we're going to form one bond. If we happen to have 4 unpaired, that means we could form 4 bonds. The same goes for 2 or 3 unpaired electrons. The most number of unpaired electrons that you can have is actually going to be 4. And we're going to see that carbon is a really important biological molecule. And part of the reason that it's so important is that it has 4 unpaired electrons. And so it can bond to 4 different things. So keep in mind that those valence electrons are what determines the number of bonds that can form between 2 atoms.